And so what we're going to do, again, this is my justification or my proof of these derivatives, okay? So we're going to figure out the derivative. Remember, it's dy dx. Make that a little bit bigger. And y is going to be the tangent of x. So I'm going to take the derivative of the tangent of x. And you probably hear me say this every single time with respect to x, because that variable is going to change come down the road, okay? And so we have no way to do that, but we do know there's a relationship. That it's the sine of x over the cosine of x. We know it's that ratio. And so now I have a quotient, don't I? And Jonah, I'm going to start at the bottom. And quotient rule says I got to square something down here, right?
Yep.
What am I going to square?
Cosine x.
So are you okay that I write it this way?
Yeah.
Okay? Because that means cosine times cosine, right, everybody?
Cosine squared x.
Yep, cosine squared x. So then, you and I come back up here, and I think I write the cosine of x, correct?
Yep.
Times the derivative of sine, which is what?
Cosine.
Cosine x. Minus, correct?
Yep.
And then I'm going to write sine x times the derivative of cosine, which is what?
Negative sine x.
You're saying that so quickly. It makes me feel good. So now I'm going to have down here cosine squared x. Well, this is cosine squared. Would everybody agree? And this is minus a negative sine squared x, correct? Because I got negative sine x here times sine x is going to give me a negative sine squared x. And so now I have cosine squared x. This becomes a plus, is that right, Jonah?
Yep.
And Jonah, this numerator is my favorite trig identity because it's
1.
1. And Jonah, what's another name for 1 over cosine squared?
Secant squared.
Secant squared x. Therefore, the derivative of the tangent of x with respect to x is secant squared x. Bingo. Done. This is what you need to know.
This isn't one of yesterday's homework problems.
Pardon?
This isn't yet one of yesterday's homework problems.
Yeah, it was one of the homework problems, wasn't it?
It is one of the best.
It was one of the best. Excellent. And did you kind of do it this way?
Yep.
Yep. Alrighty. So this is why this is true. What do you have to know? This. Does everybody understand that? So now we know sine, we know cosine, we know tangent. Okay? The big three. So now we're going to take a look at the reciprocals. So I'm going to figure out the derivative of the cotangent of x with respect to x. And Colin, I ended up with you yesterday, didn't I? Right? So Owen, do you know the ratio of cotangent?
Just 1 over tangent.
You are right. Okay, you are right. And I never thought about that. Okay? But we don't know something to use 1 over tangent. Okay? So what's another ratio? Give you a hint.
All cosine on the side.
Cosine of the
That's
sine.
weird, yeah.
Cause I wanna be, for all of these, Owen, I'm gonna be using the, quotient rule. Okay? I like it because it's a good way to review it, remember it, cause you know, I gave it to you yesterday and now you're, oh my God, that's another thing, and then now he's got another thing. He never stops, and that's true, okay? With, respect to X. So, Owen, can you tell me what's on the bottom?
It'd be sine of x,
And what am I gonna do to the sine of X?
square it.
Square, perfect. And then I'm gonna write it right here, okay?
Yeah.
And I'm going to take the derivative of cosine,
Negative
that's
sine x.
negative sine. Beautiful, you're doing awesome. Minus, now I'm gonna write cosine X, because that's already there, I just took its derivative, times the derivative of sine, which is
Positive cosine.
positive cosine X. Perfect. So now down here, I have sine squared X. Here I have negative sine squared X. Would you agree with that, Owen?
Yeah.
Minus cosine squared X. Do you agree with that?
Yeah.
They're both negative, aren't they? So I could factor out a -1, couldn't I?
Yeah.
And then I get sine squared X plus cosine squared X over sine squared X. Would you agree with that?
Mhm.
My favorite, is that still my favorite, trig identity?
Yeah.
Is it? Owen?
It's cosecant squared, negative cosecant squared of x.
You're jumping way ahead of me.
I'm sorry.
No, it's all right, you don't need to
I
apologize.
just really like this.
Is that one?
Yeah. So
It's just the opposite
1%.
order than this, right?
Yeah.
So I'm gonna get a -1 over sine squared X, correct?
Yeah.
Therefore, the derivative of cotangent X dx is gonna be negative cosecant squared X, because that's what that is. Okay? Tangent is secant squared. Everybody got that? Cotangent starts with CO. Cotangent is cosecant squared, but it's got to be negative. And the reason why is, you know, derivative of sine is cosine, then the derivative of cosine is negative sine, so you're going to get that, right? Because cosine, right, is the co-function to sine. Cotangent is the co-function to tangent. All right. Ben, you ready? I like how you say, oh boy. I'm going to take the derivative of secant with respect to x equals, and I'm going to use the quotient rule. So what ratio can I make secant? There's only one.
C 1 over
1 over what?
cosine?
Cosine, perfect. Okay? Now this 1, Ben, that's a constant.
Yeah.
Okay? So what's gonna go on the bottom?
1.
Well, this thing is
Cosine squared of x.
cosine squared x, perfect. And then I'm gonna write cosine x, correct?
Yep.
Times, that's times, the black, well, it's blue,
Yeah.
okay? Times the derivative of 1,
0.
0. Minus 1 times the derivative of cosine,
E sine.
negative sine. Right?
Yeah.
Okay. So what is 0 times cosine?
0.
0. So then I got -1 times the negative sign, do you agree?
Yep.
So I got the sine of x over the cosine squared x. Do you see that?
Yep.
Math people don't like that, it freaks them out. I don't know why, they're just crazy that way. So they rewrite it so it looks like this. 1 over cosine x times the sine of x over the cosine of x.
So 1 over cosine of x times tangent,
Okay, what's another name for 1 over cosine of x?
secant
Secant x
times tangent.
times tangent x. So, the derivative, therefore, I gotta write my words, therefore, the derivative of secant x with respect to x is secant x tangent x. Last one. So I'm going to take the derivative of cosecant x dx. Does anybody have a guess what the answer is?
Negative cosecant x times tangent x.
Oh, you are so close. You are really, really close. Negative is correct. You sure? Cosecant is correct. Cotangent x. There's gonna be cos and negative. All right. So, Ben, you're done. Matthew, you're up. What am I gonna write? What's my ratio?
There'll be 1 over sine.
So now we're gonna do the quotient rule, and down here will be what?
Sine squared of x
Perfect. Times sine of x, correct?
times 0,
Times 0 minus,
1 times cosine.
okay, everybody agree? So this is going to be negative cosine x over sine squared x. I'm gonna have a -1 over sine x. Jonah, there's your negative, there's your cosecant, times cosine x sine x. And to be honest with you, this is the very first class I've ever had that says, hey, I think I know what the derivative of negative cosecant is. Usually, it's, when I look out there, it's like a deer. You ever have a deer look at your headlights as you're coming on it? They don't know what to do, right? So I was really pleased with that. So I get a negative cosecant x cotangent x. So the derivative, let me write this up a little bit nicer. Therefore, the derivative of cosecant x with respect to x is equal to a negative cosecant x cotangent x. So it's a product of those two trig functions. And if you look behind Ariana, they're all listed there. So those are all the transcendental derivatives. We call them transcendental derivatives because it's not x to some power, okay? If it's x to some power, you just do the power rule. These ones, you don't apply the power rule because they're weird. You know, okay? So let's flip to the other side. And we will start with Tyler. Derivative of sine of x. Derivative of cosine of x.
Negative sine of x.
Perfect. Derivative of tangent. Wow, you did that fast. Secant squared of x. Derivative of cotangent.
Negative cosecant.
Wow. Squared, right? You were gonna say squared, right? You wouldn't lie to me, would ya? A derivative of secant,
Secant of x, tangent x.
and derivative of cosecant.
Negative cosecant, cotangent.
You were right, I can't. I have issues sometimes with writing C's. Notice how they're kinda all negative on the bottom, all positive on top? Like there's a pattern. Common struggles for students dealing with trig derivatives, memorizing unit circle values, simplifying, manipulating trig expressions, and trig reciprocals in the calculator. Am I right about that? We've had our bumps with the unit circle, right? Our ups and our downs, okay? All right, so we're gonna take the derivative of this, y prime. Ariana, do I have a product? Okay, so this is f times g, correct? So f is equal to the sine of x. What's f prime? And so g is equal to tangent of x. What's g prime? Secant squared x. Okay, so the product rule says I'm going to take I'm going to take the sine of x, times the derivative of g, which is secant squared x, plus g, which is the tangent of x, times the cosine of x. Let's see if we can do some simplification. Here's the sine of x. Here's 1 over cosine squared of x.
Won't that be tangent plus secant?
Or tangent times secant?
Yeah, I mean that.
Okay. Yeah, does everybody see where he's getting that? If not, I can do this. This is what you did in your head, correct?
Yep.
And so you said this is tangent x secant x. Can you see that okay? And then over here, I can say that this is sine of x over cosine of x times cosine of x over 1. Right, is everybody okay with what I'm doing there?
The red pen.
Dot, right? Okay, everybody okay with that cosine x is cosine x over 1? I can write it as a fraction? Okay, I see people nodding. So plus the sine of x, that's my final answer. Maria, what do I have here? What rule am I going to apply? Huh?
Yeah, the quotient.
Quotient rule, perfect. So this is, the quotient rule says if I take the derivative, I'm going to have something on the bottom and it's going to be squared. What is it? Secant squared of x. And then I'm going to write the secant of x times, what's the derivative of x? 1. Minus x times the derivative of secant. What's secant? Secant x tangent x. So I have this now. Secant x minus x, secant x tangent x over secant squared x. Do you agree with that?
Yes.
Okay. So I see secant in both of these terms on top and it's secant on the bottom. So I'm gonna factor out a secant x. I'm gonna get 1 minus x tangent x over, and down here I'm gonna have secant x times secant x. Maria, is that okay? Pardon?
Yes.
Then I can go BAM! It's gone. So I've simplified it. And this is going to give me, so now what I'm going to do is I'm going to put this pi over 6, and I'm going to have 1 minus pi over 6 times the tangent of pi over 6 over the secant of pi over 6. So Maria, let's say that I give this to you and you can't use the calculator. And the first thing under your breath, you would say, Kruger. So in other words, Kruger has now become a square word because you're not happy. Okay? So this is how I would deal with it. Okay? Sine of pi over 6, cosine of pi over 6. Now, do you know why I wrote it in this particular order? Because that's tangent. And so I got this little doohickey right here, and I'm right here. Correct? And this is 1, 0. This is 0, 1. And so this is the square root of 3 over 2, 1/2. I may have even written this on a piece of paper really quickly. So I come over here, what do I write up here? 1/2. What do I write down here?
Square root of 3 over 2.
Okay? So now I got 1/2 times 2 over the square root of 3. Do you know where 2 over the square root of 3 came from?
It's the reciprocal.
Right, multiplying by the reciprocal, right? Bam. So now I know it's 1 minus pi over 6 times 1 over the square root of 3. Are you okay so far? Now, here I got 1 over the cosine of pi over 6. Correct? And that's the same as 1 over the square root of 3 over 2. Okay, because I just wrote that up here. So now that's 1 times 2 over the square root of 3. And so now I know this is 2 over the square root of 3. We doing okay? All right.
Wait, if cosine's gonna have I believe cosine has a value of 1/2 at 1/6.
At pi over 6? No,
Yeah.
I think it's the square root of 3 over 2.
I thought the square root of 3 over 2 was at cosine of 3 of pi over 3.
No, it's not. You know how I know that?
Oh.
The square root of 3 over 2 is really close to the square root of 4 over 2. And that's 1. So if you look, as this angle rotates in this direction, x moves in this direction. Would you agree?
Mm-hmm.
So x has got to be the square root of 3 over 2 at pi over 6. At pi over 2, it's going to be 0. Okay? Now, I'm going to have 1 minus pi over 6 times the square root of 3 times the square root of 3 over 2. So Maria, what I did here is I multiplied by the reciprocal. You okay with that? Okay, so I'm going to get the square root of 3 over 2. This square root of 3 and this square root of 3 will be gone, minus pi over 12. And that's what is equal to the derivative at pi over 6. Alrighty. That should make you smile, right? So we want to bring out the machine. Make sure it's in radians, folks. Okay? If you have physics, it might be in degrees. Or, there might some of you guys that like degrees. I don't like degrees because they're plummeting right now. It's supposed to be a joke. They're not going over well. Yep. It's free education. I mean, if I was teaching a private school, it'd be funnier. That didn't go over well either. All right. You guys tell me what you get. Does everybody know how to put this in on their calculator, or should I show you that?
Yeah, I never knew how to put like these squared
Yeah, I'll show
trig
you.
functions in the
Okay.
calculator.
Okay. I gotta delete this stuff.
Sine.
Okay, so I use parentheses, and what is it, cosecant? So it's gonna be 1 divided by sine, and I'm gonna use parentheses 4x, parentheses, parentheses, squared. Oop, you can't see anything I wrote.
Yeah.
So I need 1 over sine, right, because that's cosecant. I need to have 4x in there. And then outside all that, I need to square it. You want me to do it on a TI also? Okay, is everybody with the Casio okay? Okay, TI. Go to y equals. We're gonna have parentheses, 1 divided by sine. See, this one comes up with a parentheses, so I can put it in there. Parentheses, parentheses. So that right there is cosecant of 4x. And now I just have to square it. Do I have to, Tyler, do I have to do it on my old one? Okay, everybody okay with that? Calvin, okay? Colin, okay? I always gotta ask to see people.
I have a Casio. I would've got it.
So you want me to do it in the yellow Casio?
No, it's okay.
It's okay? Everybody fine? Alright, so now, I might as well keep going over here. So I'm gonna go quit, I'm gonna go to my window. I don't like all this stuff. So then I'm gonna go to math. I'm gonna go to line 8. If I got a TI, press enter. If I got this form, I'm gonna put X in here wherever X is. And then I'm gonna go to vars, give Y1. And then they want me to evaluate it at, what's the number? 2. I got that. Anybody else get that? Okay. Casio people, you want me to do it?
I got it.
Want me to do it? Okay. Can I use this Casio? Okay. So I'm gonna go to menu, I'm gonna come up here, So on this, you gotta go to options, OPT, which is right here. And you're gonna go to calculus, and there's your derivative. Now mine looks different than yours. You want me to do it on the yellow one? Okay. So you don't have to put in X, it's already in there. So I'm gonna go to bars right here. You choose graph, cause that's where it is. You hit Y and then 1. And then you don't have, you put in the comma for you. You don't have to put in X, then you're gonna put in 2. Lo and behold, it's the same answer. I hope I got both these in radians. Everybody okay with that? Alright, so all you would have to say is, this is my work, and this is what I would expect to see. D prime of X, of 2, sorry, not X, D prime of 2 is equal to 1.202. Or you could write 1.201. Either one you'd get full credit. But I need to see this.
What if I do it to the as far as the decimal points that my calculator will go to?
That is, you'll get full credit.
Because it's technically still an estimate because it is rounded.
Correct, it is. Yeah. I'm just trying to save myself some time.
Yeah, that makes sense.